This conference will now be recorded. This conference will now be recorded.
Welcome to Terraform Loading. In this session, we are going to talk about how to break up the environment with a simple sample of web application server. So here, I'm going to create a directory for my web. Here, I'm going to use the EC2 instance on my AWS. So let me go into the directory which I have created, where I'm going to create a file called web ec2.pdf. Here in the sense the Terraform file. So I just create test file. So with the 3 different blocks. So any Terraform file, if you start open with the .tf file, that is going to have a provider information at the top. After that, we are going to use the next block as a resource block. So block will be within the flower brackets, and here if you are going to see, the block contains it is going to contain one part where you are going to have arguments in the left side, and the right side you are going to have the values. So in this example, I'm going to create 2 important resources. The first one which you are going to see, that is security group. So every AWS instance, the VM or virtual machine which you are going to launch on EC2, that requires a security group association. And in this, I'm going to give the access to ingress. There are 2 different options: inbound network, outbound network. Ingress and egress. Ingress is inside, whatever the incoming request will be accepted. So any port which is going to be accessing with the 8080 port, we want to open it for every request. So for every request, how we are going to mention, that is what CIDR block. CIDR block, if you are going to open, give with some specific IP address, within that range, it is going to create a subnet, and then all the servers will be having that within that subnet will be given entry point or inbound. And similarly, we are going to have the resource which we have discussed in the last session. In this session, so we are just expanding much more the AMI which we have used in the last session. So that AMI we are going to use here. So in the AMI ID, so what you are going to have, that one I'm going to use here. So this is different for every region, every AWS region. So I'm using the AP South one. So this is related to Mumbai region. So that's why I'm using this AMI. So if I'm going to work on the Chicago, or if I'm working on some US east side or west side, then this AMI won't work. So you need to use according to your region. You have to select your specific AMI. So free tier AMI to test or work with the simple link. So whenever you are working on Terraform, Terraform is going to have a chain of a resource group graph. So this first resource group is having a name. So you can have multiple values for one particular argument which you are going to have. So this name, AWS security group, I'm going to use here. So this will be will be associated with the VPC security group ID. So in AWS, you are going to have the VPC, that is a virtual private network, that will be using the user data. And this set, what I am having 20 line to 22 line. So these lines, you can write anything you want to run inside the container, inside the instance, AWS instance. Once that instance is booting, this will be running. You can run anything here. For example, smallest server I want to use, BusyBox. BusyBox web server I want to run. So BusyBox is going to run the HTTP process, and that should be exposing expose. This one will be exposed that as a front port 8080, and I want to give it same to the external users also. So whenever I'm going to say this application running, the server is running, then I'm going to get this index file open. So any web server, if you're going to have a index file, then automatically it will show the content of the index file. So here, that is a second block which is going to resource linking. So how that linking happen, that is in the 18th line. So whenever you want to link one resource with another resource name is required, then followed by the specific ID. So instance ID we are going to use. So AWS security group dot instance, then in that you are going to have some ID. So who is going to generate this ID? ID will be generated by Terraform. So Terraform automatically creates this one. Whenever you are going to create, whenever you run the plan, you can see it is going to be generated. When it is going to generate it? At the time of applying. Okay, let us try this. So up to this changes, we are done, and just save this file. I'm going back to my directory. First, if I'm going to run Terraform, then the first time I created this folder, the immediate check. So you can check
Terraform
Terraform.
spelling.
Spelling is wrong. Okay.
Spelling is wrong.
Terraform -v. So it is going to tell the version, right? So if you are going to associate with a provider, you are in which provider? You are applied some provider, or you are using one TF file. Then what happens? Then it is going to change that version, and it is going to show along with the provider name also. Okay. So let us see how we can initialize. So I'll just go with init. So first time, whenever you create a folder, you have to run the init. So it is going to initialize your Terraform project. And after reading the file, that .tf file, it is going to create a provider. So it is downloading a provider, and it is going to link up that one. So every provider, Google provider, Azure provider, each one is going to be one plugin for the Terraform. So these Terraform plugins, whenever you write 3 lines in your TF file, it will read that one, and it will automatically download that tool for you. The plugin will be downloaded and automatically integrated. Whenever you run, it is automatically works for you. All right, so that is one thing, and just it takes a while. So what else we have on this page? What we are learning? So it is having 4 blocks: arguments, resources, tags. When you're going to have the nested, so nested blocks also there. You can see here, tags is the instance block. Another block which is it is taking too much time. think is I'm audible?
Yes, you are audible too. Hello. Hmm?
Net connection problem. So we are back and executing the same. So it is trying to download from the Terraform website the AWS plugin. So all set, then AWS plugin is there. So AWS CLI is automatically downloaded and it is available in the plugins directory. So it is 2.57, and if you go for the Google will have another version, another provider plugin will be there. Azure will be having its own AZ plugin. So each cloud they are providing CLIs. So this one is also internally uses the CLI to provision the environment which is desired, which you are given in the file. So let us see now how we can execute the plan. Terraform, then plan. It will show all the steps it is going to perform as per the DF file. What you have mentioned in the DF file, it is going to validate, it is going to show us. So in this you can see lines no after apply. So when you are going to say Terraform apply, that time these values will be applied, and we are interested in seeing the value where we have modified. So tag we have modified, and other thing is about resources what we have used. So here is the security group instance. The security group instance ID you can see here no after apply. So whenever it is going to run the apply command, that time this ID value will be coming, and this ID value will be connecting to the Terraform example. So Webserver which is it is going to create. Okay. So now I'm just I'm going to clearing the screen now. Terraform apply. So Terraform apply will be working with the plan what it is showing us. The same thing is displayed over here, right? So according to the plan, it is known after the apply. So whenever you said apply yes, then it is going to create that ID and it is going to associate with the instance which you are going to create. And it is also using the ingress, so you can see the block what it is pointing, where it is showing that. So 80 port is exposed, 8080 port is open for the ingress. So as per the requirements, you can open the ports for your EC2 instance. So in the meantime, we'll just check is there any web instance on our is in our AWS console. EC2 console, yeah, it is done. Let us see once it is refresh what we are going to get. Yeah, so you can see here there are two instances. One is just initializing. Just now we have started. So Terraform web instance, that is what it is creating. So this web instance is in process. Once it is coming to the running completely 2x2, if you're going to get, then we can check the application access. So what we have made in the application, we have added a simple text message to an index file, and it is going to run with the web server. So this is what we want to run. So no hub is running without any hanging up, and ampersand means it is running in a background. So in between, what you are having, busybox httpd 80. So with this port, we are going to run. What it is containing, this is a file, a simple web server program. So there are two things. How many resources are added? It is going to show here. How many changes? There is no changes. Exactly what we have written in the plan, whatever we have defined in the definitions, that is taken up. Okay. So once this is up, let me just refresh from here. Still it is initializing. Okay. So once that is comes up, we can see the in this directory, you can see there is a file created, Terraform state. So Terraform state, you can see it is always maintained by your Terraform apply command. It is automatically generates that one. And in this one, you can see how many CPUs, cores, etc. All those details in detail it is going to show you. And here I'm going to see IP address. No, then public IP address. So public IP address, we want to use what we have for this. So this is a public IP address, public DNS, right? So just trying to use curl http / insert that IP address. What is the port? 8080. So what is the output you got? This is exactly what we have written in the resource in the web server. So namaste Terraform world. So this is a simple example where we can just say here -q. No, q is not working, means then -s. So -s is silently check that one. So it is just simply checking the web server. So web server is up and running and it is showing the index file. So index file content we are able to see on the output. Okay. So if you modify this web server, is it going to work or not? So you just add the h1 tag, right? And if you end this one, it's a simple index file, index HTML file. So I'm saving this one and going back to apply Terraform apply. So refreshing the state, and it is automatically generated another ID, and you can see that ID value comparison. So when there is no changes, then it doesn't create any new ID. So it is always creates the ID. One is for destroying. So previously created ID, it is trying to remove, and a new instance will be created. So you can see the difference. So this is elapsed the old ID. After that, it is going to create the new one. Any changes you do in the Terraform file, it is first read that, compare that. If it is there is a change, any line, any text, then it is going to destroy the previously created infrastructure, and again it is going to create. So this is nothing but immutable infrastructure. The meaning of this immutable infrastructure, you cannot replace existing instance. So you have EC2 instance already existing, you can't change a text file. So this, whatever I just trial, whatever I did now, this is not good practice. Just to modify one HTML file, we are recreating entire EC2 instance. So it is going to destroy first, then it is going to create this instance. So what is our best practice? You just need to change the file which is present in the container. So if you use a busy box, that one if you modify, that is a good practice. So you need to more segregate, divide, and you can use it, then it will be more useful. All right, so now we'll just take the same example here. Is it going to show that it's still connecting? Maybe it is still creating. Creation is completed, it is showing, but the instance, as you know, from the AWS, it takes little time to update. So it is terminated and again initializing. So once this initialization is completed, then you will be getting the latest instance and new public IP will be created for you. So previously created public IP is destroyed. Again, you are creating new one. So once that public IP is accessible, then we can use that public IP address instead of the previously used one. So that updates where you can get it from your so I'll just grab that. So the backup is also there, you can see here. So state file, state backup is also created automatically. I didn't do anything, it is automatically created. Terraform is making the backup for you. So I just want to grab public and then Terraform state. So in this one, you can see the latest new IP address. So I have to use the new IP address or DNS name. So curl -s silently and give the host and then 8080. So I'll just give the HTTP at the beginning. So you got the hello world. So if you want to use the same IP address on the browser, so I just want to check, is it going to work? Yes, Namaste Terraform world. So it is working. So web server creation with single Ubuntu instance, we have experimented and is successfully executed. Okay, so this is all about the how to use the resources and your AWS instances. So I'll just go through this theory part of today's lesson. Okay, so providers, there are different providers. We are using currently AWS provider. So next, what we can use, Google Cloud Platform. You can use Oracle Cloud Platform. You can use Azure Cloud Platform. So there are different options when you're working with the different cloud. So only thing is you need to know the providers. Who are the providers? So one command is there. So Terraform providers. So if you are going to see here in this terminal, you can see Terraform. So Terraform provider. Providers. Yes, if you miss, then you will be getting there. So it will show Terraform providers. So how many providers? Only one provider. With the same DF file, you can run two clouds. You can use Google Cloud, you can use AWS with the same program. So that is possible. So if you run one Terraform apply command, it will work on both. Okay, so that is the power of this Terraform. So right now we are able to see what is the provider. Similarly, yeah, so what is the syntax, how we are going to work with that? So we can have a couple of providers, AWS, Google, Azure, etc. So we'll see some of the examples there. Okay, so Terraform resources, what are the resources, what are the blocks, and how we can build that one. So in a high level, these are the Terraform commands. If you want to see all the help, Terraform, just hit enter, it will show automatically help. Or you can say Terraform -help, it will show the help. Terraform -v, this will be giving you version. So Terraform -v, previously it is just shown this one liner. Now it is showing Terraform version plus AWS version. Provider version is also showing. If you are going to have one more resource inside the same file, TF file, that will be added to this tree. It is going to create a graph. So in data structure, there is a graph, acyclic graph. So acyclic graph, here you can see one resource is linked with another. So this is one point, another is this point. So graph is directed graph. What is directing? AWS security group is directing AWS instance. So this is pointing, linking. So what is pointing to what? We can see with the simple Terraform graph. Yeah, so it is showing all the linked things, instance, if you see here, and security group. You can see from the root, it is going to have the linking path. So the first one is instance in top-down approach, you can see here, and that will be linked with the AWS security group. So how this is linked, what it is happening, if you have more and more detail drill down into more resources or more sub blocks, then you will be get to know about all those things. Anyway, so DI graph, direct graph, so that is the thing. The next thing is about you can, whenever you start a project, you are going to use always Terraform init and provider we have seen. And then you can have the plan. Whenever you want to verify the syntax is correct or not, then we are going to use the Terraform plan. Terraform apply is actually actionable thing which is working on the plan which is shown. So you can store a plan and you can run that one. So how we can store a plan? We can think of destroying this instance. Just now we have created the instance, web server is running. That instance you want to remove or you want to destroy from the AWS. So how do you do that? We can just create a plan dash. So you can see a lot of options are there for plan. If you want to see the help, so you have different options. So you can use all these options. So I'm using this destroy option. I want to destroy the instance. Destroy is option. And I want to create a file, out file. So whenever you want to store something, output, you can give the name of the file. So I'm giving web destroy dot plan. So it is going to store the plan into this file. It is assessed, it is refreshing, and it is then storing. So the file is here. So within the current directory, you can see web destroy.plan is created. So you can see it is always having all minus things. So what you are seeing in the output, it is going to destroy. Whenever it is creating, it is always giving green color plus, but when it is going to destroy, it is always giving red color minus symbols. So whatever you are seeing on the screen, that will be stored in this file. You can see with VI or you can see with the less command. Okay. Yeah, you cannot see the plan file. Plan file is binary file. So you cannot edit, you cannot read it. Okay, so plan will be work. If you want to use this plan to destroy, you can use that one. Okay, so that is another level of learning. So here Terraform destroy is the next command which we can perform to destroy the existing. So Terraform, okay, so Terraform destroy. It is going to remove the instance from the EC2. So you can see it is started removing, terminating. So let us refresh the last instance which we have, Terraform web instance. So this one will be destroyed now. So it started destroying, and you got the terminated statement. All right. So that is about destroy. Then what is Terraform providers? There are a lot of providers, as we have seen. So a provider is responsible. So it is going to understand what API is going to given for that particular cloud. So this every cloud, if I'm going to use a GCP cloud, I'm going to use. So if I'm going to use Azure is going to have its own API interface. So that interface is going to connect. So whenever we just give the line provider, automatically it will create that one. So there are a lot of types of clouds, as you know. So there are IaaS and PaaS clouds, SaaS clouds. So Oracle is a SaaS cloud, PaaS cloud, HERCO, and all other general clouds are your IaaS. So Terraform can work with any type of clouds, and it is simply uses the DNS simple. It is also work with the Cloudflare, so which are another set of tools which are provided by the cloud. So when you're working with this Terraform, there are variables, there are blocks which I just explained in the beginning of the session. So if you want to use that arguments, so I'll just give the example here in the code. So whatever you have here in the light blue color region, this is a argument, and it is always associated with the value, and it is a string. So name and value always in string in double quotes. So it might be having a set. So it is going to have a block of values. So this one is also a argument, and it is having a block. So if you are going to start a block, it is always in a flower brackets. So arguments ascend values with a string. Image ID, something if you are going to see in the example, image ID you are going to have number. Block will be having multiple labels. So these are multiple labels. The right side, left side, if you see, right side is always having values. In the left side, it is having labels. So to port, from port, all these are labels, and all these considered as a one block, that is ingress block. Similarly, you can declare the egress block also if you in advanced level, next level. The next thing you can see identifier block name arguments. So whenever you are going to use the block, so this is a resource block. This is another resource block. So whenever you are defining a resource block, this is a block which is not having any name, and this is a block which is having some names. So you can have multiple names for the same. So that is possible, and we can also have nested blocks. A block can contain another set of blocks. And if you want to give a comment, you can give using the hash, you can use double slash, you can use just like Java style, slash star, and ending with the star slash. So these are the different syntaxes which you can use in your Terraform variables and blocks. So that is a simple basic about Terraform coding. So coming to the interactive way how we are going to use, so Terraform is going to connect with the different provider plugins. So right now what we are connected, how we are checking, that is AWS. So if I'm going to write something about GCP, then it is going to create GCP plugin. So I'll just check that one. Is it going to create a GCP plugin or not? So if I'm going to write something like this, it is a Google provider. Okay, if I'm going to copy this and put into the same code, test web, and save it, and then go back to your So it is still waiting for my response on the destroy. So all resources which are created, they are all going to be destroyed. So it is going to show each and every line. So whatever you have seen in the graph, all those IDs will be shown first and they are going to be destroyed. So destroy part is over. Two resources are destroyed. Okay. So now if I'm going to say here, Terraform apply. Again, it is going to create or it is going to give error. So provider, I got an error. So there is no suitable version installed. So when you are going to add a provider, if there is no provider in the directory, then it is going to show this one. So immediately, what is this meaning? What is the error this is saying? So it is trying to connect to the plugin. What I'm saying here, in this, there is a plugin, provider plugin that is not available. That's why it is not able to talk. It is going to talk with the GCP API. For that one, we need a plugin. So how we can get that one? We can get it with the init command. So Google is going to give us its CLI command. So Google provider and you have AWS provider. So whenever you just say here now Terraform version, you can see two providers, AWS provider, Google provider in the list. Okay, so it is not disturbing anything on EC2 or AWS. It is just created another provider. The plugin is created now, and that is ready. So whatever you want to do with the GCP, you can do. Whatever you want to work on the AWS, that you can work with that. Both you can do from the same file. But going forward, as much as you divide and rule, or as much as you say simplify, that will be more useful. So resources all you can keep in a separate file. All variables you want to keep in a separate file. That will be always good. So variables or resources, you can separate it and store into different TF vars. So TF vars means Terraform variables. So Terraform variables you can store separately and you can work with that. You can define your main program requirement, what you want to do with that. So that is the segregation you can do from your main Terraform HCL code. So that is a basic thing. Yeah. So there are different providers as we are working and learning. So AWS is one of the best provider and most common requirement is AWS provider. Okay, so if you are going to work with the provider, what are the things what it is going to offer us? So whenever you want to connect with the provider, AWS provider, you need a credentials. We created with the IAM user created, and there is authentication, access key, and secret key. So those things we are going to call as the credentials. So these credentials you can configure with the CLI, or you have to provide in your Terraform file. So the following methods are supported in the order, in this order. So it is going to spend in below. Static credentials, you can keep everything in your TF file. Environment variables, you can define as environment variables. That is what I'm doing in my example. So I'm not using username or a secret file or the credentials. I'm not using in the TF file. Shared credentials. So shared credentials is some more advanced thing. So you are going to share across multiple instances. So you are going to use the username password that will be accessible. That will be creating multiple instances. So in that case, you have to use different rows, EC2 rows. So you have to define role and you can use it. So that is related to the AWS. So if you are going to work with the AWS, the static credentials means the static credentials can be provided by adding access key. So There are two things, access key and secret key. So access key, secret key will be provided when you create the user in the AWS. And the IAM, you are going to create that and you are going to get these values. So I'm just giving my access key and my secret key. In place of that, you have to replace that one. So these things are basic things for creating the credentials. So AWS provider will be working or connecting with the AWS cloud with these parameters. So what it requires: region, access key, secret. So these three things required. So if you are going to work with the environment variables, this is what I'm using: AWS access key and secret key. So I just added these environment variables, and it is always using this. So I'm using AP South 1, and here in the example US West 2 is there. So you can just simply run the plan, and it is going to take the environment variables. So you can check, you can test the environment variables credentials accessing that. So provider is the simple one line. You can say you are having so and so region, and you can give the path shared credentials, where the shared credentials you want to store. You can give the location. So you may use Windows machine, you may be using Linux machine on the AWS. So anywhere it is possible, you can run that one. So if you are working on the Linux machine, you have to give the absolute path of that one, where that credentials are stored. So the credentials means secret key and these two values, access key, secret key. These two values what you have, that you are going to keep in the creds file. .aws creds file if you are going to store, and you just need to mention shared credential file. So it is going to connect with this username password, and it is going to perform whatever you want to do. So Amazon EC2 role, if you are going to define, then within the AWS, within the cloud, you want to communicate and run the Terraform. From that instance only you want to do all the things. Then you have to create a role in the Amazon EC2. So most commonly used service, that is you can create the user virtual machine, and you are going to use in the virtual machine the choice of configurations. So EC2 standard form is Elastic Compute Cloud. So EC2 is going to use the assume role and role ARN, session name, external ID. So these are the values you have to provide. So whenever you go for the role creation, you will get all those things. So account ID, role name, session name, external ID, all these values are coming from the EC2 role. That is about AWS accessing part. Then coming to the Google Cloud Platform, if just we have seen that example. So in provider line, we are just giving the Google. So Google Cloud, it is going to connect. And how to connect? We are going to use the credentials account.json. So if you provide the account.json, it will apply and it is going to work on that one. So in our example, we are not using any resources. We are not creating any virtual machine in Google. So that's why it is just connecting, and that's it. It's not doing anything. So one project ID, or which region you want to do, that is fine. You can give the values and test it. So plugin is created for you. The GCP terminology, if you're going to work with the GCP, you have to download Google Cloud SDK. Google Cloud SDK, it is going to work with the Google CLI commands, Google Cloud Platform, that is GCP, Google Compute Engine. So just like EC2, we are going to create the virtual systems or virtual machines on Google. So these are the words which you can see. Then coming to the Terraform, you can work with the Terraform. You have to just say, okay, so the example, I'll come with the example in the next section on Azure Cloud. So whenever you are going to use Azure Cloud, you have to download the Azure CLI, and you have to create the authentications. So authentication here in the Azure, we need to give the 4 parameters. So just like your AWS, you're going to use access and secret key, plus you're going to give the subscription ID. Subscription ID is important when you're working with the Azure Cloud. So service identity, service principal, client. So these are the three parameters it is going to take to connect with the Azure cloud. Okay, so these are the things which you can as credentials, you can use as a credentials in Azure. Going forward, on resources. So we have just learned about what is resource, how we can use. So you can link one resource with another resource using the variables. So you can define the variables within the Terraform. You can define the variables outside the Terraform file. That is tf-vars. We are going to use the file extension. It is automatically sends from the current directory. You don't need to give the exact path. So in the current directory, if you give some file, it is automatically reads that file. Is there any tf-var files are present in that? So you can create, you can declare some blocks, and you can use that variables. Okay, so that is about resources. So if you are going to see the Terraform resource lifecycle, so whenever you are going to start, it is going to create resource, and you can work with web applications. Then you can just simply take, it is going to create. Create is the first step. So create command performed, then create state you are going to get. After that, it is going to read, then it is going to be in read state. After read, then it is going to update with the values what you have in the text file. So you can modify, you can change anything, and that will again creates. If you want to delete any resource file, you can delete. So this is a simple Terraform resource life cycle: create, read, delete. So that's all about Terraform resources. Okay. So resource, if you are going to see in detail about the one simple example, here is a resource, queue resource. Here is another resource that is about storage. So something you want to send some data to this storage, you are going to use a queue. So SQS is a queue in AWS. So that queue you want to use, for that one you need access again. So you need to use the access key, secret key, in which region, all these variables you can use, and then that will be, it is going to be accessed. It is going to use in the different, so here you can see AWS region. So that region you have defined here, AWS region. So that we are going to get that value here. And if you are going to see app name and other things, how you want to give the access, you want to give the private access, public access, that you can mention. So resources, you can link one resource with another. You can have blocks in your program, in Terraform program. So it is overall, so far what we learned is resources, how we can create, how providers works. So in the last example, we have both providers and resources. So provider, AWS or Google or Azure. The variables you can declare, and you can use just like shell variables. You can use a dollar, then followed by the flower brackets. Inside that, var dot, whatever the name of the block that we can mention. So AWS region here also we are using, and that will be used in both. So importing disk, exporting, importing will happen from the storage. So import will happen from the queue. So that is what we intended to work on the S3 buckets. Okay. So that is a simple example about how we can define a resource in AWS in bigger projects. So that's all for today's session. Any questions? All right, so we'll connect back on Tuesday. Thank you guys. Bye.